We're talking linear inequalities today. So far we've done lines, and then we're taking a step away from systems for a second, but we will do systems with these. And so, keep in mind our fresh time little thing that we did to start class. A linear equality, it's similar to the linear equation. It's similar. We have the same reference points, but it uses an inequality symbol instead of an equal sign. All right, and so when we're talking line, xy satisfies the line. It's all the points on the line forever. When we're talking inequality, the line kind of becomes our reference point, and then there's all these ordered pairs that work, right? It's like infinite more infinite answers kind of. And keep in mind, when we had something like x equals 3 on a number line, it'd just be 3. If we had something like x is less than 3, that 3 would become our reference point, and we'd have to interpret what that means, right? Same kind of idea is going to happen with these lines. The first thing I want to make sure, and we did this with fresh time. Remember you gave me like ordered pairs that worked? And then I didn't even do that didn't work because like 5 billion pounds of asparagus obviously would not work, right? So there's some that don't work too. So in your notes you can see that 2x minus 3y is less than 15. I want you to test these ordered pairs and tell me if they work or not. Do they satisfy the inequality? So before, if they satisfied the equation, left side had to equal right side, right? In this case, it's going to be a little different, right? It's going to have to make this true. Left side's going to have to be less than right side. Let's start taking a look. Let's use some different colors here. So if I slap a 2 in there and a 5, 4 and negative 15, negative 11, is that less than 15? Yep. Okay. Slap a negative 1 and negative 7 in there. I get negative 2 and positive 21 for 19 is less than 15. Is that true?
No.
Nope. It's 2 times 3 minus 3 times negative 4. Is that less than 15? I got a 6 and a positive 12 for 18? An origin, is 0 less than 15?
Yes.
Yes, it is. Okay. So, notice, we're not having to land on the line to make it true necessarily. Okay, in fact, if we landed on the line, let's say we got 15, is 15 less than 15?
No.
So in this case, the line wouldn't even satisfy it, right? The line can become our reference point. Okay, so I want to look at that first example on your front page. I'm going to skip the steps. You know me, I stinking hate steps. Because I want you to understand what you're doing and why. And that is why we will have a Unit 7-8 test at some point. Because, like Unit 7's lines, right? We're still just messing with lines like this whole time. So, let me see what I want to do. What color here? There we go. Regular play. So, when I see standard form, what do I keep telling you I like to do if I can? To graph it.
Intercepts?
I like the intercepts. I've got a 7.5 intercept here, which is not really good a vibe. So if the intercepts aren't working great, what do I need to do to graph it? Convert it to slope intercept form. So I'm going to isolate my y variable. And there's going to be something happening right here that you might have forgotten from inequalities. But maybe it happened in your Khan Academy. What do I have to do with my inequality when I divide or multiply by a negative? Got to flip it. Remember, because it changes the relationship between what's large and what's not. Everything becomes its opposite. So really big things can become really little things. Right?
That's only for dividing, right?
Multiplying or dividing?
Oh, multiplying or dividing.
Yeah, because multiplication is division. Division is multiplication at this point, right? With the way the reciprocals work, right? I can make any multiplication problem a division problem. Any division problem a multiplication problem. So, here's my same line. Y is greater than 2/3 x minus 5. Don't forget to flip it because we divided by a negative. So to graph this, I have a y-intercept of -5. 2, 3, 4, 5. have a slope of 2/3. So a rise of 2, a run of 3, puts my next point right here. And then what we've got to do for a line, though, is does our line work?
No.
Our line does not work. Right? It has to be greater. It can't be the line, it has to be greater than the line. So I'm going to do a dashed line. This line, when it gets hungry, calls its buddy door. Okay. So then we need to decide where the answers are. When there's slope-intercept form, there's kind of an easy way because it's in reference to y. And y on a graph tells us which directions. Up and down. So if it needs to be greater than this, it'd have to be above the line. So we would shade up here. Okay? The other method that always works is picking any point. And you don't, as long as your point's not on the line, it's never a wasted test. Because if it works, you shade that side. If it doesn't work, you shade the other side. Because every point's either going to work or not work. So what do you think is the easiest point to test?
Probably the origin.
The origin. So I can also slap 0 in for x and y. That would give me 0 is greater than -5. And is that true?
Yes.
Yes, so the origin needs to be in the shaded part. So you'd shade that part. Let's say the origin wasn't true. You don't have to waste that effort. You just shade the other side of the line to make sure that the origin isn't in the shaded spot. So then you might be saying, well, what happens if my line goes through the origin? You can use any point to test. So like 1, 0 maybe, or 0, -1, or something that's whatever point you want to test, you can test. Right? So also let's make sure. Let's go 6. Let's go 6, -6. So should the ordered pair 6, -6 work or not work?
Work.
6, -6 would be like
No, wait, not work.
not work. So let's test it out. Okay. So 2 times 6 minus 3 times -6 needs to be less than 15. So I've got 12 plus 18 is 30. Doesn't work. Good, because it's on the side that's not shaded. So you can check any point. The origin's the easiest point to check. Cool. Let's have y'all try out number 2 on the back there. Numero dos.
Why number 2? Why not number 1?
Because the one that we did ended up being like number 1 because I changed it to slope-intercept form. Let's take a look at this graph. I've got a y-intercept of -1, which is right there. Got a slope of -2, so a rise of -2, a run of 1. There's my other reference point. It is solid. So make sure that your line is solid. That's ugly, I gotta fix that. Is that it? Boom. Okay? Because the line works in this case. It can be less than or equal to that. Less than, since it's in slope-intercept form, means below the line. Okay? We can also test the origin. Should the origin work or not?
It should not.
Should not. So let's test out. Is 0 less than or equal to -1? No.
Yes.
So good. It's good that it doesn't work because the opposite side of the line is shaded there. Cool? I want you now to try out number 4, please. Try out number 4 on your PDF, please. You got a couple options on this one. Which way would I go about graphing it, you think? You guys know me. Yeah, intercept. So, just out of curiosity, did everybody make this one slope-intercept? Because you can. If you made it slope-intercept, make sure you flip the symbol this time, right? But I'm going to do intercepts. I know my x-intercept is 8, 0, and my y-intercept is 0, -2. 1, 2, 3, 4, 5, 6, 7, 8. Here's my x-intercept. Here's my y-intercept. Am I going to be a solid line or a dashed line? Yeah, the line doesn't work. It has to be less than, right?
Wait, what? What? I did mine going the other way.
What do you mean other way?
What do you mean that the lines go both ways?
So there.
It was a negative line.
No, this would have a positive slope.
Oh, I
So if you did turn it into slope-intercept,
Oh,
you would subtract x.
You're right,
You
you're right,
get
you're
in
right.
1/4, positive 1/4.
Yeah, it's all right. Let's do it. I can do it quick. Let's look at it. But you'd have to flip your symbol, okay? -2 up 1 over 4 up 1 over 4. It still works. Same line, right? Okay. Now, this is the reason I like testing the origin. If I test the origin in here, it's pretty easy. 0 is less than 8. Is that true? Yeah, so if the origin's true, it needs to be shaded. So the origin needs to be in the shaded portion. Also, if you do it in slope-intercept form, it's greater than that, so it needs to be above your line. But the reason you have to test it out is look what this symbol is in standard form. It's a less than symbol, right?
But it gets divided by a negative.
It gets divided by a negative if you go slope-intercept. So test. It's so easy to test the intercept, the 0, 0 though here, right? Because 0 less than 8. That's all your test is. All right. I need you guys to try one more. Number 6, please.
Just go back.
Yeah.
Have you ever seen the constipation movie? It never came out.
Yes.
Oh,
heard that.
kill me.
You know,
Joe told me.
Well,
that.
you know
It's
what?
a solid-
All right.
Wait, but that
So-
means we can't test it.
Yeah. So you can't just graph. You can't just graph this with intercepts. Now what you could do is you could do something like, well, you know the origin 0, 0 works, and you could do something like plug 2 in for x and get another point, right? Because remember when we first started graphing lines, we did x, y tables and graphed like a bunch of points. Do you guys remember that? We moved on because there's easier ways, but what I would do for this is actually I would solve for y. Now I got to be careful, especially since we've been doing a lot of equations. I'll accidentally write a equal sign there instead of a less than sign. So I know my y-intercept is 0. Rise to -3 or run up 2 is second line. Now am I going to be solid or dashed here? Dashed, right? Because the line is not going to work because it needs to be less
You
than.
never flip the symbol.
Correct, because I did not divide by negative.
Oh, it's only when you divide.
Only when you multiply or divide because it changes the relationship between things that are large and small.
Wait.
So, we also can't test the origin here. But we could test like 1, 0. We could test 0.10. So if we did that, we'd have 3 is less than 0. Is that true?
No.
3 is not less than 0. So 0.10, which is right here, cannot be in the shaded part. It tells me this would have to be the shaded part. Another thing we can do, since this is in slope-intercept form, is it says less than in reference to y, which means below. That's another way. Cool, y'all.